I'm going to share my screen because I have my terminal as well, and Asif, and I don't know who's organizing the Lash as well. Thanks a lot for the invite. Everyone that's joining, I see a lot of people joining there. Thanks a lot for taking your time and be here to to watch this session. There's always something to learn, and I'm glad that we can can pass. That's 10 p.m. for me, but I'm still awake, I promise.
Yeah, we are really excited about your session. Thanks for for your session.
No, my pleasure, my pleasure. Yeah, for some reason I cannot share here. The share button on Teams are not
Oh, okay,
enabled for
just a
me.
minute. Sorry, I think it's my fault. Let me make you presenter. Can you try now? Sorry, I actually
There you
missed
go.
it.
That's okay. I'm going to share that one. There you go. Just a sec. Let me move you guys here to the top. Yeah, can you see my PowerPoint there?
Yes, I can see.
The wrong screen. There you go. Okay, let's go talk, a little bit about what I call cloud native environments with Azure Kubernetes Service. If my name is Jorge Arteiro, like I said, a cloud developer advocate. Some people call me Jorge, but in Portuguese, they say Jorge or George, like American, how you can call me, you want to call me. That's my profile there. I'm on this cloud native team where we work with Azure Kubernetes Service and all, container products on Azure. And if you don't, the developer advocate team is kind of a global team at Microsoft with around like 80 people where we help around all the Microsoft products. And on the cloud native team, we have only 5 people work on these. And if you never watch a session from me, you probably saw that before. That's the community that I helped to create back in early 2020 when COVID came and everyone locked down and we start producing like videos and blogs. And if you want to follow us and subscribe, I appreciate. There's azuretar.com or Azuretar or Azuretar is like a tarball, a zip file for Azure. We have like 115 videos and almost 40 blogs as well. And if you want to record in your language or record something, just let me know. I'm very happy to organize a time and record something with you as if with your community, let people know that if they want to share something, that's the place that I can help you to share content. And before we start on Azure Kubernetes Service, I want to explain a little bit about local development on Kubernetes. A lot of people say, why I need Kubernetes? Why, how can I get started? And the way that I like with Kubernetes is in containers itself, is looking for one of those products. I'm going to show Docker desktop. Anyone using Docker desktop? Just put the hands there on Teams. Then I can know that. Or you can use something like Rancher Desktop as well. Or you just, if you want to go hardcore, you can install Docker yourself on WSL. But if you want to go this way, you just let me open the chat here. I don't know if you want to ask something, just put your question on the chat. I'll be happy to try to answer as soon as possible as well. But I see people using Docker Desktop. And how you create environments? Kubernetes, they have like various distributions that you have. You have like the full Kubernetes, or you can have something like K3S. That's a lightweight version of the whole Kubernetes, where everything runs in a single binary. Means a single binary runs the whole cluster. And that's the K3S. That's part of the Cloud Native Compute Foundation as well that you're going to see. what that foundation means for Kubernetes. And when we started on containers, the first thing we do is Docker desktop or Russia desktop, or you get like a Kubernetes dish or like micro-K8s, or you're also using something like Kind and K3D. Why you need those things? It's like we're going to use Kind, we're going to use Docker, but at the same time, we want to play with multiple Kubernetes classes. And that's very heavy. And then if you use K3D and Kind, it can create classes on Docker. Means that it can simulate or emulate like a full Kubernetes cluster inside a Docker container. It's like simulating a whole cluster inside a single container. And you're going to see that how that works. And that's the start. I would recommend, probably Docker desktop or Rancher desktop, one of those two. And then what we do next? We have to understand what a Docker file is. I know that if there's any .NET developer watching this, .NET now is going to bring something that they can create a Docker image for your application without like even a Docker file. A Docker file is the main way for you to package your application to deploy inside like a Docker host or a Kubernetes cluster. Because we're going to talk about Kubernetes today, I'm going to stop talking about Docker and only talk about Kubernetes and how a Docker file works. You have to define what's your base template. Remember the virtual machine template? We're talking about now a template for your application. What are the dependencies that you need to deploy your application? That we call a base image on containers. Someone is asking for the link for the YouTube channel. I'm going to put it here. Give me 1 second. There you go. youtube.com Azure tab. Going back for the Docker file. The Docker file, you need like a base. If I'm a .NET developer, I'm going to pick probably ASP.NET 6 as a base image. Okay, I get everything that I need to run a .NET application, just one time, not like SDK or anything, just a lightweight image where I have like, it's like a Linux, let's say VM or Linux distribution where you're going to deploy application. And I'm going to open like port 443 and port 80 and just define the work directory for my application. Then I keep this apart, okay? I say, keep this, that's my base image. Now I'm going to define how I'm going to build this application. Then I create another front. It's completely independent from the first one. That's what we call Docker multi-stage build. We have multiple fronts, and each front runs in parallel. They run the first one, they create the base one. They run the second one to build the application. Then they're going to copy the code. They're going to run the .NET restore to get all the NuGet package. Then they're going to copy this on the work directory, and they're going to run .NET build. Okay. That's the second one. If I go back here, that's the second one. Now I have two steps. The first step is the base. The second one, we build the application. What we need after build, we need to publish the application. Then I create another step. It's like a pipeline. A Docker multi-stage build like a pipeline. Each one run in parallel. But if you notice, I'm starting now from the build. I'm starting from the previous step. I'm getting everything I done on the previous one, and I'm going to use to publish. And if you notice on the build, I'm not using the ASP.NET. I was using the SDK as an image because the SDK, I have everything I need to build .NET. But I don't need that in production runtime. Now the third step, I'm going to publish. And the final step, that will be the green, I'm going to copy everything from the publish and create my final image and define my entry point for the application. That's the DLL that I created that was compiled. And what happened? Everything disappears, and now we have two layers. We have the base and we have the application on the green, and that became what we call Docker image, where your application is there, and you kind of deploy your application inside this Docker image. Once you learn that, you can deploy anything on Kubernetes. And you now have a what you call a container image or Docker image with your application deployed there that you can run anywhere. There are multiple Azure services where you can run this. Any question on Docker image? I think the first step is to learn Docker image. You have to understand why we have those steps. And what we do, if you see on this diagram here that I have for many years already, that's exactly what we did on the Docker Sage build. We got the code, the source code. We run the Docker build. We save these inside like a Docker registry. And if you never use, on Azure, we have one thing called Azure Container Registry, ACR. That's like a storage for our Docker image. Then we save this on this Azure Container Registry. And now we can deploy this image from anywhere. And the easy way to deploy on Azure Kubernetes Services and even in Docker, but I'm going to focus on Kubernetes. You could get this image and you could deploy on your local Kubernetes. Remember the Docker desktop, Rancher desktop, kind, K3D, K3S? You could do that. Means any Kubernetes distribution will be the same way to deploy. And the way that you deploy is like using command line. The command line, the CLI tool for Kubernetes called kubectl. Or you can use some things that creates like a deployment processing on top of these. That's called like Helm as a package management for Kubernetes. We get these and we deploy. We're going to see how that works and how those images that we just talked about, they have layers, as you can see on the diagram here, means that we don't download this image all the time from the registry. The local environment where your application is running, like say a Kubernetes cluster, you're going to cache those layers. And once you deploy the version 2 of your application, let's say you change something and you have to redeploy your application, the only thing that's going to change is the last layer. You don't have to redeploy the whole thing. That's how container works. They cache all those layers. And because Linux and now Windows as well, they both are based on files, means that the only thing that you need to deploy are like all the file systems of your container, of your application. Let's go for Azure now. How can we get this? Now I understand that to deploy something on Kubernetes on Docker, we need like a Docker file. We need to build this as an image. We have to store that in a container registry, then we deploy. On Azure, we have a few servers where you can deploy this. Today, we're going to talk about Azure Kubernetes Service, but you can see Azure Container Apps is a full serverless platform. Azure Kubernetes Service, you don't have to manage the infrastructure, but you can see that you are able to do it. But you're going to see that Azure Kubernetes Service today, maybe if you saw 1 or 2 years ago or 3 years ago, was more like infra-based. Now we pretty much have a fully managed service. It's not fully serverless, but it's fully managed. It means that you don't have to care about patching virtual machines or anything. Because what's a cluster? You're going to see that's a cluster of what's a cluster, and you're going to understand what I'm saying. But the main points on Azure, you have a few of those servers on the cloud native space, including something called Azure Arc. Azure Arc allows you to not only manage the clusters that are inside Azure, but you can also manage classes that are outside. And I'm going to show one running here from my laptop, managed by Azure Arc. Okay. Now, Azure Kubernetes Service. While I was talking about virtual machines and cluster, what's an Azure Kubernetes Service cluster? There's nothing more than a control plane that's completely hidden from the user. When you go on Azure portal and you create Azure Kubernetes Service, you're going to see that you cannot see the control plane. The control plane is managed by Microsoft, by Azure, and you can, including SLA if you want. You don't pay for that, but if you want a full SLA for your cluster, you are able to pay, and we recommend that for production. Then that blue box there is a black box, a blue box where you don't touch. We manage everything that's part of the Kubernetes control plane. Okay. Then you go for the what you call node pools. Once you create a cluster, you need at least one node pool. It has to be Linux. But today, if you don't know, maybe a few people don't know yet, you can deploy things on Linux, Windows, or ARM64 on Azure Kubernetes Service. Means that when you decide to create those pools, you can pick one of them. And I'm going to show one ARM64 cluster running ARM64 applications as well. And even better, I'm going to show how you can scale those pools to 0. And when don't pay anything for Azure Kubernetes Service, you have to pay at least for one pool, what you call agent pool. You're going to see that. But for your application running, you're going to be able to scale to 0. And I'm going to show one cluster where we have one Linux pool and one ARM pool, and you're going to be able to scale this ARM pool to 0. And there's another thing called Azure Container Instance. Azure Container Instance is another product on Azure where you can deploy like a single container or a single pod. Pod in Kubernetes is more than one container. It's like you deploy multiple applications inside the same Linux namespace, the same namespace in sharing like CPU, memory storage, things like that. That the Kubernetes call a pod. And if you want to go fully like serverless, you can also use Azure Container Instance integrated with Azure Kubernetes Service. Means that you can say, look, I have this cluster running some applications, but at night I have to run hundreds of containers just to process like some image overnight or to do some background job. I don't want to scale this cluster up and down all the time. I just want to run in a serverless offer. You don't have to go for Azure Functions or anything else. You can use Azure Container Instance and deploy application the same way that you deploy with Helm, with kubectl, the same way that you deploy here. And how that works is something that we call on Azure Kubernetes Service called virtual nodes. It's based on that virtual kubelet project. It's part of CNCF. It's an open source part of the Cloud Native Compute Foundation, where you can define like a fake node pool, where anything that you say deploy on my cluster, they're not going to deploy really inside the cluster. They're going to go on Azure and deploy using Azure Container Instance. That's very nice. And this project including even you deploying all the clouds if you want. That's how it works. But the nice thing is those VMs that you're talking about, you don't have to manage yourself anymore. That's why I'm talking, there's a fully managed service. You can set those node pools to be outscalable, means that on Azure Kubernetes Service, there are two ways to scale. One is scaling the cluster, the infrastructure. You can just say, great, give me a node pool and just outscale. Means that if there is no CPU and memory available on those VMs to deploy my application, just create another VM. Just scale up. If I stop the application, just scale the cluster down. Means that I'm just going to pay for the number of VMs that I need to run my application. And you can also scale to 0. That's the virtual kubelet that I was talking about. It's like a fake node. You just create another node, like I just explained. And then you can do like fully serverless, but keep using the Kubernetes API to deploy application. And that's that's what I call a Kubernetes cluster. Jorge, what's a Kubernetes cluster? It's nothing more than a bunch of physical machines or virtual machines, what you call nodes here, where this control plane that we don't pay for, that, that blue box here, that's the control plane. That's on the left side. We used to call master, but it's like control plane. They expose files one API. And in Kubernetes itself, the open source Kubernetes is an API. You just talk with this API, you send your YAML file, what you call manifests, explaining what you want to deploy. I say, I want to get this container image, and I want to run 5 instances of this application, and I want to scale this way. I want to open these ports. I want to expose this in a load balancer. You define that. And you send this YAML configuration to the API server. And this API server get your request, store that in a database called etcd, and they start looking for the scheduler, the piece of software that's going to try to deploy your application. They look for your nodes on the cluster, on those node pools, those VMs, and they look for CPU and memory available on those VMs to deploy application. When they found, they go there, they talk with this thing called kubelet inside each virtual machine. That's how the communication works with the nodes. And they deploy the application. Then there is one thing called container runtime. It used to be Docker. It's not Docker anymore. It's now using one thing called containerd, and they deploy application. That's very high level, but simple is better to understand. You don't have to really understand the whole thing to use Kubernetes. At the end of the day, you as a developer, as an infra person, are going to talk with API server. We manage all these nodes and all that control plane for you, even patching the nodes. And how that integrates with Azure. When you create a cluster, we connect that. If you use something called Azure CNI, that's called Container Network Interface, is a way that Kubernetes integrate with the cloud providers and the networks. It's kind of, let's say, a driver or that we have to talk with with Azure. And that Azure CNI, you can use there are other options as well. You can, for example, one way is to deploy a cluster and say, every time that I deploy one container or like a pod, where my application is, I want like an IP number from my VNet. Then become pretty much very similar to like a virtual machine. When you create a virtual machine, you have IP number on that VNet where your virtual machine is deployed. When you deploy a container on Kubernetes, you can also get like IP number from the virtual network. And another thing that you can do is like integrate storage. For example, you could have like a Azure disk or Azure file connected to your application there as well. And before that, there is another thing that's called kubeproxy that does all the magic to, when you call your pod, that IP number, all the IP tables on Linux machines, all that connection is done by the kubeproxy team. But the main thing is there is a driver that connects. There is a provider or Azure CNI that connects that. And that's like how Docker works for a long time. Okay, if you forget Kubernetes and you look just for Docker, how you install Docker and you do like a Docker run or something, Docker has a daemon, like a D, that talks with containerd. Containerd is a high-level library, okay, that understand about Docker image, understand about the container runtimes. And what Dockerfile does when you do like a Docker run, just talk with containerd and say, hey, can you run that for me? Containerd is going to do all the magic. That's why Kubernetes now doesn't use Docker anymore. They only use containerd. Means that Azure Kubernetes Services is talking directly with containerd and say, can you run my application? And then in Linux, there is one runtime called runc that goes and create like a isolated space called namespace on the machine where your application is going to run. So that cluster have like 5 virtual machines. If you're going to deploy on virtual machine 1, they're going to create a namespace inside that virtual machine where they're going to isolate your application. Means that if you have like 5 or 10 applications running on the same physical machine or virtual machine, they're not going to be sharing the same memory, CPU, and storage. They're going to be isolated. That's why we say that containers are not like a virtual machine. It's isolation by the Linux kernel or by the Windows kernel as well. And that's how it works. On Windows, we have the same. They call the Windows Server container on top of the Windows kernel. But we also have one thing called Hyper-V containers, where we create an extra layer of isolation around your container, that you call Hyper-V container. I'm not going in details on that. But if you someone wanna know more, let me know, ping me later. And there's another thing Microsoft creates called Linux container on Windows, and that's how Azure Container Instance runs Linux and Windows containers. They run Linux containers on Windows on Azure using what you call LECAL, where we have a lightweight virtual machine on top of the hypervisor on Windows, where we run like a Linux light virtual machine to run your container. Then you can run Linux containers on Windows. And by the way, that was, the technology that made Windows Subsystem for Linux, WSL, possible. That came in from here. If you have Windows Subsystem for Linux that you're going to see soon, that's where this comes from. And very low level, if you like the low level, because a meetup, people want to go very deep, I put this slide here. And that's how it works on Kubernetes today. That kubelet that runs on each virtual machine, on each node, just talk with a containerd and creates a container. Containerd is going to run the containers. And they're using gRPC connection to be very fast at communication with containerd from the kubelet. The kubelet runs on the node, on the physical machine, okay, on the virtual machine. And then talk with that containerd that runs on each node, and then should just run your application. And does all that CNI network integration that we discussed before. And that's pretty much how that works on Kubernetes, going a little even further down on the containerd and the plugins from the kubelet. That's how it works. And I have one example of deployment here. Here's a video, okay? Going to see application being deployed from GitHub. That's ControlsOR. Maybe you have watched this video before. Sorry, that's a video I want to show today. Let's say that you clone your repo from GitHub. You get this on VS Code. And now VS Code have extension to run something called draft. And you run this command called AZAKS draft create. And I'm going to stop here just to show what that command does, AZAKS draft create. They're going to create a Docker file. Remember the Docker file that I was showing? You can say, Jorge, I don't know how to create this Docker file. We're going to create the Docker file for you. And draft is extension for Azure CLI. Okay, it's an open source project. And now we have extension on VS Code that you can install. It's called AKS development. They're going to detect the language that you're using in these applications as JavaScript. You're going to tell which port you want to open. You're going to explain you want to use Helm, the package manager that you want to use to deploy on Kubernetes. They're also going to create the Helm chart, what they call the Helmet deployment file, the YAML file, so deploy application. They're going to create that for you. Expose the port 8080, put a name for the application. And now, as you can see, we have the Docker file here created based on this one, and we have the Helm charts as well. And now we're going to create a GitHub Actions workflow to be able to not only build your application, but deploy your application from GitHub Actions. And then generate workflow is another command. And at the end of the day, you're going to have three things. Let me go back a little bit. You have, you're going to push this to GitHub. Oh, sorry, I went back too much. Yep. You see three things, but the Docker file was the Helm chart and was the GitHub where the workflow is. That's what the extension AZAKS draft created. I'm going to put here on the chat, AZAKS draft. You can install that and have disabled. How that works, once I push this code to GitHub, now I have a Docker file, I have a GitHub Actions, and I have the Helm chart to deploy the application. Once I push this code to GitHub, that's going to trigger a GitHub Actions. That's going to get the Docker file that I was showing on the first slide. That's going to build this image. Is going to store that inside Azure Container Registry. And they're going to build using Azure Container Registry. Azure Container Registry is able to run Docker build. Then once that's done, everything is run, they're going to deploy applications running. And if I go back a little bit, you can see that all the steps. Yeah, I can show that in one later for you. And once your application is deployed and running, there is also another thing I want to show here. Is a new product that Azure released for anyone using Grafana dashboards. If you're using, just put on the chat there. Yes, yes, or something. But Grafana, yep, there's someone using that. Lash is using Grafana. We now have a fully managed Grafana available on Azure. And with a single AZ Grafana command, we can create a fully Grafana instance connected with Azure Kubernetes Service, and you can use to monitor and do all the operations for your Kubernetes Service from Grafana dashboard. Sounds good? I think if someone doesn't want to use the Azure monitoring dashboards, that's a Grafana dashboard there with a fully managed service where you don't have to manage Grafana yourself. Before I go ahead, I'm going to stop these. Let's go. Stop this demo for a while here. I'm trying to bring my. I hope you can see my screens. First thing I have here is I have Docker Desktop, like I was showing before. And I have something called kind running. Then I'm going to show what that kind means. I have also Visual Studio Code. If you never use it, there is an extension for Kubernetes on Visual Studio Code, where you can, for example, you can select this cluster kind, and you can see everything that's running on there. Or you can go for command line, and you can also run kubectl, get nodes, and you see they have one cluster running there. And Docker is running. For the Docker PS, That's where this kind class is running, is a container. I'm simulating a container inside a full class inside a container. Kind is a command line that you can install, and you can create these classes. You can have multiple. If I do kind list, kind class list, I think. Get that. Yep. Let's go again. Kind get classes. You can see I have 2 classes. And then when I run nodes, I can see everything that's running on this cluster. And a nice thing, you can see the same on the VS Code extension. And if I go here in deployments, I have to go namespace. Look how many namespace I have. If I go kubectl get all, I get everything that's running on this cluster. And as you can see, this cluster is connected with Azure. See Azure Arc here? What I did, I onboarded this local cluster that's running on my laptop on Azure. And I also install Azure Open Service Mesh. That's a service mesh for Kubernetes. I'm not going details on that. Microsoft Defender is running here as well. And some other things like Gatekeeper for Azure Policy to apply Azure Policy on this cluster. It means now, a cluster that's running on my machine or could be running anywhere, on-premise, the cloud, you could be managing this from Azure. And now I'm going to show where is this cluster. If I get my source group, Kubernetes service, I have 3 clusters here. And one of them is this one, Azure Arc. This Red Dog cluster is running on my machine. It's exactly the cluster that you just saw here. Everything that's running here, all these pods running is running here locally. But let's try to see them here. The Azure portal is integrated using Azure Arc to the cluster running on my laptop. The same things that I will show you on my laptop, CMDC, the same pods that you're going to see there, we see here. That's exactly the same. That's run here on my machine, and you can see and you can manage it from Azure using Azure Arc. And even better than that, you can install those extensions on those classes. Imagine this cluster running on AWS or on Google Cloud or on-premise on your data center. You could install those extensions like I did. Like Azure Monitoring is running on my local cluster on my machine, Azure Policy, Microsoft Defender. Microsoft Defender, if you don't know, you can pretty much, using Microsoft Defender and scanning for everything that's going to be deployed on your cluster and in what's running as well in runtime. Then if they detect any virus or any instance of like a container that's like has a CVE, or they're going to show you that. And you're going to be able to see on that security preview thing. They're going to give you the recommendations from here. I don't have anything running there yet. And all the extensions like GitOps, Open Service Mesh, policies. I could apply a policy running to apply a policy on the cluster running on my machine. I hope you enjoy that. If you enjoy that. I really like that. But I want to show the class I was talking about where there is ARM64. If anyone have questions, just you can open the microphone or just write down the question there. I have another AKS cluster By the way, if you don't know, you can just create from the portal a cluster. Very simple to create. But I have this cluster here with node pools, and I have 2 node pools. The first node pool is what we call agent node pool. Why? Because we need at least one node pool where, you know, what we call the Kubernetes components has to run, like a DNS, everything that has to run on your side. And if you go on these nodes, just one. I have 3 here, but you don't really need 3. For production, yes, it's recommended like 3 nodes. For development, by the way, you don't need to have all these multiple node pools. I'm sure more like a production-ready cluster where you have like an agent pool, and you can see the workloads running on these. And they are mostly all the things that you are managing yourself, all the extensions like Open Service Mesh, Container Network Interface, Azure Disk connections, Azure File connections, Open Service Mesh, Azure Policies, all these things you have to run somewhere. And that's why we run on this thing called agent pools. Okay. And the other type of node pools are user node pool. See, system node pool, that's called agent pool, or user pool. User pool is where your application is going to be deployed. You just need one system node pool, but you can have multiple user node pools. Let's say you want to isolate applications. If you have multiple applications that you want to deploy on the same cluster, you can isolate those applications by user pools. Means that you're never going to have like a noise neighbor. You know what's a noise neighbor? You deploy something and there's another application from someone else that's going to, you know, be competing with resource. No, you can isolate using node pools. And that's how that works. What I did, I created an ARM node pool, and this node pool is using one VM size on Azure that's for, say, Linux, but ARM 64 image. And I did even better. I create this node pool saying that I enable the outscaling for this node pool. I say maximum 3 nodes. I don't want to go more than 3 nodes. Just my development here. I could put more. I could put like 1,000 nodes. And I set outscaling. And I also did a configuration that's not showing here, but I said every time that you deploy something after 3 minutes, if you don't need it, just scale down. That's not scaling your application, that's scaling the physical machines of your cluster. They're doing all the job for us. But I did something even better. I said, look, I don't want to delete the VMs and create the VMs all the time, because if I have to scale back up, I want to do that like in 20 seconds, 30 seconds, or less than a minute. I don't want to wait for Azure to create a VM to scale up and down. Remember Azure functions that you want that warm up to be fast? You can do the same on AKS. You can set this node pool to never delete the VMs. And as you can see my nodes, at the moment, I have 1 node running ready, and I have 2 nodes stopped. Why? Because I don't want to pay for those things. I'm just pay for 1 node, and for the other nodes, I just pay for the storage. And you can even scale to 0, because if you look my configuration, enable, I'm set node count 0, means that I can scale to 0. Okay. Let's do like a test here. Let's see how that works. Let's see if I have the file here to do it. I think I have here. See, this deployment is this application here called, let's try to, that's the YAML file that I deployed this application. Okay, I deploy a Blazor application on ARM64, and this application is running on this cluster. If I go on workloads, by the way, on Azure Portal, you can see everything that's running on your cluster. I'm going to select my namespace. And as you can see, I have one deployment with 5 replicas. That's exactly from this file here. I asked for 5 replicas. And I said that I want to only run these on ARM64 nodes. And I want to expose a load balancer for my application. And if I go here on service, there is a load balancer. That's how Kubernetes works. They create a load balancer where my application is running. That's it. I should add this running here. Not sure. Yep, I have the application running here. Okay. That's my Blazor gig. If I go on pods, I select the same namespace. I have 5 instances running. That's okay? All good? 5 instances. Let's do like a simple command line scaling up and down just to show the difference here. But for that, I want to maybe go pods. Yeah, let's go. I have 5 instances running. What happened? On this node pool, I just have one single node. Blazor. There you go. As you can see, I have 2 tabs here, one with my application, 5 instances running. Another one, I have 2 nodes in standby. What happens if I go on my command line and I deploy that? kubectl apply this AKS file. Okay, but before I apply, let me put like 25 or I don't know, 22 instances. I don't know how many I can support there. Let's say 20 instances there. Okay, that's the same file that I have on command line here. I'm going to deploy now 20. I think I did the wrong class, but let's see which class I have. Yeah. Okay. Sorry, I'll just make sure that I'm on the right cluster. Yep, there you go. That's the same cluster. Now I'm going to deploy. You can see nothing changed here because the application is already deployed. I'm just changing the application itself. I have to go be quick on the browser, refresh, and you can see already how many instances I have running now. Few. And even better, I want to go on the nodes. What happened is, you see that they deployed them a few instances on the node that was running, node number 1. Those other one waiting here, they don't have capacity on the first node to deploy. Now they're waiting, they're pending for the second node to come up. That's going to take a few seconds because I haven't deleted the node just to start the node again. Yep, second node's ready. Now I should see the other instance start getting deployed as well. Yep, it's all running now. That was like seconds. And now I have 2. If I go again back there and I deploy like, let's say, 40, and I hit deploy there, and go back quick, same thing is going to happen. Now they have all this pending where they don't have capacity on the nodes. On these 2 nodes here, they don't have capacity. They need the third node to be started to deploy that. That's how Kubernetes works. If you understand that, you pretty much understand how the magic of outscaling works. and you're going to see a few seconds, those ones pending. Let's go refresh. Everything's running now. I have just some of them pending for one node with CPU and memory available. And which CPU and memory, George? That's the CPU and memory that we need. Remember the deployment I was showing there? You need 0.1 CPU and 128 meg of memory to deploy your application. If they don't have one of these nodes available, they're going to start the third one. Yep, they already did, and everything should be running here. There you go. Now I have 40 instances running. And as you can see, for the minutes, everything I was showing here took 3 minutes. Look at it, 3 minutes ago, everything took 3 minutes to come from one node to 3 nodes. Now let's go back and say I want to go back for 5 or 0. I want to go back to 0. 0, I should see quickly the pods terminating. Yep, your application is not there yet. You scale to 0, and now you're probably asking how long it takes for these things to scale to 0. I did my set in 3 minutes. It can do it. The standard on AKS is like 10 minutes, but you can change this profile for the time that you want. Let's see if I have this probably here. It's something like that. You can deploy a profile like this. Okay. You can create like update a node pool, and you can always put some taints if you want to do like the ARM64. It's something like that. So if you want to look for this later, you just set the 3 minutes, and then that's the way that I create the node pool. Then I updated setting like a profile for 3 minutes. And I also put like a taint, a restriction to only allow deployment of ARM64. And if you look on my deployment, I'm also asking for these ARM64 nodes. You need this to be able to deploy. A toleration for the taint. It's like saying, I only want to deploy my application on nodes with this key and value there. How long takes, let's see, how long takes to the cluster to delete the nodes or to stop the nodes. So you haven't messed up here, but I think still 3 minutes on this class. I'm not sure, but any question in the meantime? We can came back for this one, and I don't know how long we have. Is 1 hour already, and you have time for questions or?
Yeah, I think you have a time, so that's not an issue because we have only one session today. So yeah, and
What do you think? Does it make sense? This
yeah, it's
helps
really
and
nice.
when I send the
For
cats.
start for a beginner, I think it's really good to have a start. I mean, like how can we understand the Kubernetes architecture and the node pools? Yeah, it's really interesting to see how the replica is, scaling down. So yeah, I used to also think that if we have 0 replica and if we delete all the replica, how it will be. So yeah, today I'm seeing live. Thanks, George.
Yeah, there are some things that people not using a lot yet. That's like the ARM64 is available now. It's not in preview anymore. Means that you can use in production. And that scaling that I was showing here, I think is very important that you can, you're able to do that. And you can set the cloud start scale profile. And you can see there's a lot of things that you can change on that configuration.
Yeah.
And yeah, I hope this scales down to 0, but yeah, I don't think I have anything running anymore there on this class, on these node pools.
And Today means we have learned also the AKS draft command, which is like me and Nilesh firstly both were discussing like we're not aware. So it
There
was
you go.
nice.
There you go. I'm not that. See, not ready. Is it scaling down now?
Right.
Yeah. Second one. Stop it. Means that. Yep. The third one will be soon. Mean that scale to 0. You don't pay for this ARM pool, just for the time that you run your application. And if you don't want to wait for 10 minutes, you can change the scaling. Depends of your application, of your requirements. You don't want to put like 3 minutes, if you don't want to scale down and up all the time. But like in development, you probably maybe don't want to do that. That was just to show that you can scale down if you want.
So can we scale up and scale down based on the CPU usage? Any?
Yeah, there is one thing called that was, if you have a little bit more time, I could explain these, but these like Kader. And then probably switch from here. Kader, you can install Kader. People are discussing this a lot on Azure Container Apps because it's there already installed. But on Azure Kubernetes Service, you have a extension add-on for Kader, and it's the same as Azure Container Apps. Then you can do any of those metrics you can use to scale your application based on events. And let's say how many messages on the queue you have, you could scale up and down your application. I was showing here just to show the cluster itself. And that's a different scaling that we're talking about here. That's application scaling. I was talking about the cluster scaling. Say two type of scaling. One thing I have to care is the cluster give you, SQL in memory to deploy. Another one is when to deploy based on events. Kader is the way, really, you're right, is the best way to do. And you can enable just an extension. I think if one of these commands I was showing here is, I think you can enable Kader, this one.
Yeah.
Just enable Kader, you're able to enable Kader in your cluster. See, I have enabled this one, but I haven't done any demo to show. And yeah, that's just things I'm working on. And yeah, pretty much that. Pretty much like I said, the Kader. Another one that you can install is DEPA, is another extension. The same that you use on Container Apps, you can use on AKS. If you go on all these options that we have, Azure Monitoring, Open Service Mesh, GitOps, those things very similar that I was showing on my cluster that's connected with Azure Arc.
Oh, okay.
And I hope that all makes sense. And yeah, see, now I have all the 3 nodes scaled to 0. And there you go, my demo work. Live, no videos, everything scaled to 0. And yeah, it can scale to 0. It's not fully service, but it's a fully managed service with Windows, Linux, and ARM. Remember that Azure Container Apps is just for Linux at the moment. There is no ARM there. There is no Windows. Azure Kubernetes Service, you can do the whole thing. You can do service mesh. You can do whatever you want. Yeah. And you can use all the Azure policies and Azure Container Hash integration. I recommend always just play. If you want to play with containers, play with container apps. If you are a beginner, then you're going to start, connecting the dots. In some stage, you're probably going to production on AKS once you understand how that works.
Yeah.
That's it. I think that's my demo for today. We could talk here about Kubernetes for a long time. You guys know that. But
Thanks, Joe. Thanks for a wonderful demo and session. I have one question. Like for a beginner, to start, you mentioned that we can start with the container apps. So basically, how they will decide? It's like we should go for the container apps or AKS or some other services in cloud. For startup.
Yeah, look, my opinion, to be honest, is like it's not one or another. It will be both. You're going to use most of those services together, and you're going to find out which one works better for you. I always say container apps is very easy to get started. You can deploy, but you're going to see that not everything you can deploy there. Maybe if you talk again in 1 year, maybe we're going to get more use case being possible to deploy on container apps. But for example, TCP ports, they're not yet there, but they're getting close. Means that if you want to start, just get there. Don't go for problem app service now. If you want to containers, go for container apps.
Okay.
That's my recommendation. Where you can get a simple application deployed there, then you don't care about the infrastructure.
Yep.
Then you can start playing with your local environment, understanding that. And what I see is some developing process will be on container apps, but production will be on AKS. You understand? Maybe some UAT will be AKS as well. Depends on your environment. If your application is simple enough or don't have any of those requirements for like a AKS cluster, means like a complex networking, like a service mesh or anything, probably container apps will be a solution that you're going to use. But when you're talking about companies with different networking,
More
then
control on
probably
infrastructure.
then AKS is a solution. And we make AKS so easier now that there are so many possible configurations, and all the cluster management is done by Azure itself. See the nodes, you can patch the nodes in different way. You can even schedule the management of the nodes. And we just released the integration with the Azure management, the schedule management, the maintenance management for Azure. Because AKS used to be separate, now is also integrated on Azure management, and you can manage AKS schedule, for the updating the nodes from there as well. It means that you can say just do on this time of the, from 2 to 4 a.m. You can say that as well. When we're going to patch the nodes of your applications, of your cluster. But you don't have to do that yourself. We even patch the nodes that are not running, because there's two ways to scale down. You can scale down deleting the node, or you can scale down like I did, just to show that you can keep the nodes live. The difference is the warm up is like heaps faster than deleting the node and create again. Another thing that is scaling down is on the case that you don't have these on container apps is doing the scaling down like I did. We keep all the caching of the container image. Then it's not just the time to start your node, it's also the time to download the image from the container registry. You don't need it because the image is already there. And then, it's not just faster because it's just stop it and start the VM again. It's also the storage that's already there. And in the future, we're going to bring even more improvements like teleport. Teleport will be something that we're going to improve this caching of the Docker images on the cluster. We just released, I think it's going to ignite next week. We're going also to clean up your nodes and delete all the images that you're not using anymore. And there's another feature that was just released. I haven't even tested yet, but it's there. It means that you don't have to care about deleting, all the image from the cluster. They're going to clean up for us.
Nice.
ARM64. I think that's the main reason to use AKS is like when you need more complex. It's hard to explain for someone that never used, containers because it's like different variables. But once you start using containers and Kubernetes on container apps, then you start to understand the variables, the way that you scale, the way that you that your application communicates between the microservice, if you need a service mesh or not. For example, if you need like container network different from Azure CNI on AKS, now you can bring your container network. Is another feature that was released. You can install like Cilium on AKS now from CNCF. Means that AKS, we give all the flexibility for the expert users, but we give the out of the box for the initial, like for the medium users or people that just getting started with AKS, where they don't have to do anything. And just there is an option now when you create a cluster to select like a developer cluster.
Okay.
And that bring you and give you everything that you needed. And yeah, I'm counting with you guys to create videos and more things. And if you want to publish something on Azure, I'm happy to do that as well. If you have anything that you want to record or you have done before, you want to record again, to show all those features for the community and for the users. Is any feature that anyone is using that you want to talk about, or say something about like something new that you are looking for to test, or any feedback? I appreciate if I have a feedback for us as well.
I think Nilesh is the best person for this
No?
because he's always
Okay.
trying something new.
Yeah, I can share something that I've been trying recently. So for past, I think 3 or 4 years, I've been using KEDA, and I've tried things like auto scaling the containers based on messages like RabbitMQ, number of messages in the RabbitMQ, and right from KEDA when it was in preview, I've been using this one sample application, and I think you touched upon all those key areas, George. Like I've used the Azure container instances to do scaling on the ACI when you have burst kind of capabilities, and then also use KEDA for the scaling of cluster. So where you scale infrastructure of the underlying Kubernetes cluster, and then when you want to go serverless, you also use the ACI container instances with virtual nodes. I've been experimenting a bit with the Dapper and Azure Container Apps, the new features. And I had a question in mind for you. Typically now people are moving more and more workloads to serverless kind of scenarios, right? So when it comes to serverless, I think there is still a bit of confusion which service to use the best. So is it the ACI? Is it the AKS with, let's say, KEDA, Dapper, or you go with Azure Container Apps and then you use Dapper and KEDA, which is provided built in on Azure Container Apps. So maybe based on your experience of working with these services, what do you recommend? There is Azure Functions as well, so you can also use the functions runtime and run it independently. Right?
Yeah, you could run Azure Functions with KEDA on AKS, and a lot of people do that. I think you have to use what's better for you, both your application. It's not one or another, it's both. I see people using both, and with these scales that is to zero that I was just showing, you don't need ACI. You probably can do this way. You can have a node pool scale to zero. You don't pay. You don't have to set the node to be on standby. You can delete the node. Then you don't even pay for the storage. And you can set the outscaling to like 3 minutes, meaning like stop at 3 minutes to be down. And you have to compare how many things you have to run, because keep in mind that one node in a cluster can run a lot of things. One Azure functions you pay per execution and for how long is running. Imagine that you can run like maybe 50 Azure functions in one node or more at the same time, maybe more, even more. If you build very lightweight, Azure functions will be like, like, I don't know, 50 megabytes, 100 megabytes to run that. And because I guess you don't even need like Azure function, you could run with anything, but And once you stop, you can stop and scale to zero. Means that you're not going to pay. Okay, if you have a cluster where you have other things running, that where you're, the system node pool, you're paying for that already. Why not, run some things in a separate node pool that you can scale to zero? You understand that? You have a production AKS cluster already, where you pay for the system node pool. That's the only thing that you need to pay. Then you just create an extra node pool. So where you're going to run things that scale to zero, or you use Azure Container Instance. That's a lot of people never use, but once you figure out that you can do that, you just you do it. And to be honest, you can have a system node pool with one node. You don't pay much for that. Maybe $50 or something a month, or $100 just to run, the control plane. And another thing, you can stop the cluster as well.
Yeah, pause it.
You can stop the whole cluster. If you're just going to run things overnight, you could just start the cluster just like minutes before, run everything, then stop the cluster again. And, and you have the same way to deploy applications using AKS. Then you don't have to figure out how to, deploy using multiple different servers. You're going to use the same way using Kubernetes API to deploy. I think that takes some time for you to learn. But to be honest, once you learn that, you don't want to go use the other service anymore. Then that's what I'm saying. Until you learn that, you're probably going to use multiple servers, and you become more expert. You're going to see, oh, okay, I can run most of the things here on AKS. And we are trying to make this easier. If you remember, like 2 or 3 years ago, we don't have KDA. We used to install KDA ourselves. Now KDA and DEPA are extensions, are add-ons. Means that it's become easier and easier. And we update that for you. You don't have to update KDA. You don't have to update DEPA anymore. They become very similar to container apps, but very flexible, extensible, and you can do whatever you want. I think that's the main thing. But thanks for the feedback. I appreciate it. And
yeah, it does make life a lot easier, as you said, just having those extensions instead of we managing things like KDA, Dapper, even Service Mesh. I assume at some point Service Mesh would also become like an extension. And
it is already, yes, it is already, yeah.
Yeah.
Monitoring, Defender is extension, and then Service Mesh, all the KDA, DEPA, they're all extensions, and GitOps, another one that is in Flux.
Yeah.
And there's another one that I really recommend you to use. You can use on AKS to deploy applications. And I have some videos that I did on that. It's a very nice subject, GitOps. It means that's all there. If you look close, is everything there, even, Defender, everything there. And it's very easy to do multi-cloud, to run things on premise and on the cloud as well. Even very complex, customers, you can figure out what service you can use. But don't forget about, App Service is still a nice product. It's getting even better and better. If you're using App Service, at least migrate to App Service v3, where you have more features. Like App Service now, you can run gRPC service there. You saw that? Means that the other services are catching up as well, bringing new features. The main difference, just to finish, is the main difference between App Service and AKS is the way that we scale the application. On App Service, for each instance of your application, remember the 40 instances that I was showing there, 5, then 20, then 40? To run those 40 instances on App Service, I need 40 instances of App Service.
Yeah.
Okay, there is no way to run 5 pods or containers on the same node on AKS or on App Service. You understand that? Even if it's a, like a 50 megabytes Go microservice, you cannot run like 5 or 10 on the same instance of app service. Because for app service, instance is a new node. You pay for another instance of app service. Then become very expensive.
Complex.
Then app service is very good for 1, 2, or 3 instances. But once you compare with AKS in terms of scaling,
then
it's very hard to compete. But I like app service. But that's, for me, that's, I mean, once they fix that, they, in some stage, they're going to bring a solution for that. But it's not there yet. And yeah, I have been discussing like once they have these app service, yeah, be a good option as well. If you're already using that, you don't have to move. But if you want to use microservice and scale to more than 5 instances, it is going to become very expensive there. Because app service is very tiny things, and you can run like maybe 5, 10, 20, 30 on the same instance. And that's, I think, the main thing.
Thank you, George. Thank you, George. So it was a really nice and wonderful session and very interactive, sharing session. So you guys, if you have any questions, so you can unmute and ask. And if not, then we are, I think, by end of the session today. And we have our upcoming session on 20th of October, which is already announced on meetup.com. So if you haven't, registered yet, please do. And thanks again, George, for today's session. And maybe we'll try to do something on Azure Tar in upcoming, record a video with Nilesh, hopefully, and see something.
Let's book and we can do together. We're 3, and if anyone else want to join, let them know. And yeah, pick a subject, could be AKS, something that you're using. We can record that. It'll be amazing. Thanks a lot, everyone.
Thanks.
Have a good night there.
Nice session.
Okay, see you.
And keep in touch. Let me know if you need anything. Give me feedback. Ping me anytime, okay?
Yep.
Thanks a
Thank
lot.
you.
Bye.
Thanks. Bye-bye.